So we're going to start off this week with a review of Kirchhoff's laws, the voltage law and the current law. They're displayed here. This was the slide from last week. So the voltage law said that in each closed loop in a circuit, the voltage gains are balanced by the voltage losses. Whereas the current law says that at each junction in a circuit, the total current flowing in equals the total current flowing out. So I built a pretty big circuit here on the circuit construction kit. And right now, all of these switches here are open. So I'm going to close them all and the circuit will be working. Okay, so this is a parallel circuit. I see 3 loops in here. So when I'm analyzing using Kirchhoff's laws, I analyze 3 different loops. I'll just draw them out with my mouse here. So starting at one terminal of the battery, I can go down and go up the first pathway here where there's a resistor and a light bulb, meet this junction, and then come back to the battery. Okay, so that's one loop. A second possible loop starts at the battery, goes across to the second vertical section, go up, and then back to the battery. And the third loop would be basically the perimeter. So starting at the battery, going down around all the way to the last string here, up and back to the battery. So there's 3 possible loops in this circuit. Now I'm going to actually change things up a little bit. I've got 2 resistors here, one for each of the first 2 pathways, and right now they're the same. And you can tell they're the same because of the colors of the bands. So I'm going to click on one of them. I'm going to increase the resistance to some other number. I'll make it 20, where it started at 10. All right, so I just wanted to change the values up a little bit. So now you can see these 2 resistors are different because the colors of the bands are different. Okay, all 4 light bulbs are identical. Okay, I did not adjust anything on any of the light bulbs. However, even though all 4 light bulbs are identical, you'll see that they are shining different amounts. Okay, that's because they're each in a different part of a circuit, and there's different resistors connected to them, so they're going to shine a different amount. And actually the goal of this week is to, well, this week and next week combined, is to learn about that. All right, so I'm going to start by analyzing the current rule, I guess, just because I've got all these ammeters plugged in. So I might as well just talk about those values. So the current rule, Kirchhoff's current rule, says that the current flowing into a junction must equal the current flowing out of the junction. So I'm going to start at the battery. At the battery, I put an ammeter right next to it. So it's reading the current flowing through this strand right here, basically. And it's saying that the current is 1.29 amps. So remember, that means that on average, 1.29 of these blue dots, these coulombs, are passing through per second. And that's actually going to be the same current starting here, going through this light bulb, through the battery, and through this ammeter down here. All of that, the charges are going at the same speed of 1.29 amps. Now, this is the first junction right here where the current reaches. So according to the current rule, this 1.29 amps going into this junction must equal 1.29 flowing out. So the current flows out in 2 different possible directions. Some of it's going up here, where I see a current of 0.35, and the rest of it should be going to the right, where I see a current of 0.94. So if I add these 2 numbers together, 0.35 plus 0.94, it equals to 1.29, which is exactly the current that was flowing in. That's Kirchhoff's current rule. Voltage going into a junction equals current going into a junction equals total current coming out of the junction. Now I'm going to follow this path, 0.94 amps. It goes to the right and reaches this next junction. So same thing. I've got 0.94 amps flowing into this junction. And flowing out of this junction, I've got two directions. I've got one going up, which I see 0.24 amps. And I've got one flowing to the right, where I see 0.71 amps. So when I add these two together, 0.24 plus 0.71, that equals to 0.95. And you'll say, oh, but Mr. Tang, 0.95 is different than 0.94. Well, I'm guessing that it has to do with rounding. Okay, I think it has to do with the rounding. It's off by just a little bit. All right, so that's the current rule. I could analyze these two junctions up here as well, but it would be the same. It'd be like a mirror image. So I won't take the time to do that. All right, now voltage. So for voltage, I'm going to need a voltmeter. This one's going to be a bit harder to show. I'll stick it right here. Okay, so first of all, I'm going to measure the voltage for the battery. So I take my red needle, put it at one end, my black needle, put it at the other end, and it says 20. I'll put it here. There we go. Easier to see there. So it says 20 volts for the battery, and I set it to that. Okay, if I click on the battery, I actually set it to 20 volts. All right, now let's look at the first loop. So in the first loop, what is there? There's a resistor, a light bulb, and another light bulb. So if I do the voltages of all three of them, they need to add up to 20, which is what the battery is giving. So let's make sure. We're going to have to keep some numbers in our heads here because I've only got one voltmeter. So this is negative 3.53 for the resistor. Now I'll move to the light bulb. Negative 3.53 as well. So I got two negative 3.53s. That's approximately negative 7. I'll just do approximate. So that's approximately negative 7. So what do I expect this light bulb voltage to be? Well, it needs to be negative 13. So that the negative 7 and negative 13 make negative 20 to balance out the positive 20 from the light bulb. So let's check that. And it's negative 12.94. Okay, so it works. Okay, these three voltages add up to negative 20 to balance out the positive 20 volts from the battery. Now I'm going to show you something else with the voltmeter. So I measured the voltages of the resistor, this light bulb, and this light bulb individually. You can actually measure multiple at a time. So I can actually measure the voltage drop across the resistor and the light bulb, so these two. I can actually measure the total voltage drop across these two things by sticking my red needle at the start of the resistor here and sticking my black needle at the end of the light bulb here. Okay, so now it says negative 7.06. So that's the voltage across both of these together. And you know what? I can actually take my black needle. So my red needle is right here at the beginning of the resistor. Now if I take my black needle and put it at the end of the other light bulb, it gives me negative 20. So it's measuring the voltage from here all the way to here. So it gets all three of them, and it adds up to negative 20. What if I take my black needle and I put it on the other side of the light bulb? So just move it right over here. Well, then it's negative 7. Okay, because now I'm just measuring from the start of the resistor to this point. So I have not actually gone through my second light bulb yet. So that's why it's only at -7. All right. So we can check the other pathways. So this light bulb right here, just remember that was -13 volts. Okay, I don't have to measure it again. That was -13 volts. I'm going to check the middle path, or the second pathway now. So I have -13 from here, and then this resistor is -4.7. So -4.7 with -13 makes -17.7. So then the remaining light bulb better be the leftover to get me to 20. So like 2.3-ish. And I got -2.35. All right, so the three of them, so 1, 2, 3, these three voltages, which form the second loop, they add up to -20 to balance out the +20 from the battery. And we can check the final loop. Okay, the final loop goes through one light bulb and the other light bulb. There's no resistor in the final loop. And so that means that these two light bulbs need to add up to -20 volts. So this one is -13-ish, we know that. So this light bulb by itself should be -7-ish to add up to -20. So let's check. And it's -7.06. Okay, so that is Kirchhoff's voltage rule. Basically, there's three loops, and in all three of these loops, they got to add up to, each individual loop has got to add up to balance out the voltage given by the battery. All right, the last thing I'll talk about are the switches. So I put a whole bunch of switches here. So depending on where you put the switch, you're going to cut off some electricity. So I'm going to start off with this switch right here. I open the switch right here. I actually shut off the entire circuit, because as the electrons try to go through any one of these three pathways, no matter what, when it tries to get back to the battery, it cannot get past this open switch. So this one switch controls the entire circuit. Whereas this switch right here only affects this strand here. Okay, opening this switch cuts off this strand, but the other two pathways still have a path back to the battery. You will see that the currents have changed. Okay, it was 1.29 before, now it's 1.14. That's because it's a different circuit now. Okay, I don't have electricity running through all three. I only have them running through two. We'll analyze that later this week. I switch here similarly, open that switch, and that only controls this second strand, but the other two light bulbs will work. They have a path back to the battery. And finally, this switch here, if I open that switch, I shut off the last pathway, but the other two pathways still have a way back to the battery. All right, I got one more switch in here, which is right here. If I open this switch here cuts off these two light bulbs. Okay, however, this one still remains on. Okay, so now I basically have turned my circuit into just one loop, a series circuit now. This switch here has now cut off both of these. All right, so that's a review of Kirchhoff's laws. We did the same thing last week with different examples. This one was a much bigger example. You did a Google form last week for Kirchhoff's laws. I'm going to get you to do another Google form. We got to keep practicing Kirchhoff's laws.